Okay, you just finished the It's Elementary activity to see that your S filled first, and then your 2S, and then you had P's filling up, and that you've got to fill each orbital before you move on. Quickly, I wanted to show you what the D orbitals look like. You're not going to find a simulation that's going to show you filling up the D's. Reason being, look at these things. These guys are crazy. So this is one D orbital. This is another one. This is another one. Another one, and another one. And these guys all layer on top of each other. And so the thing is that simulations are really hard for you to do this and stack them on top of each other. And so I've never seen one, found one. I know other people that have looked to and tried to create them that show all these guys stacking, because it just gets ugly and it's really hard from a computer standpoint. But after 4S, you would come back and fill in the 3D orbitals. And so you'd start with this guy, put one electron in. And these electrons here, you can see it kind of lighting up, are being recognized by a blue and by a red. And so you can see those little shades that are lighting up, and that's just telling you the electron's cruising around. That's what the electron would be. After putting one electron in this D, you would add this one on top of it. You'd add this one, this one, this one, and then you would go back and then put another electron in here. So I just wanted to show you what the d orbitals look like, but as you can see, this is a whole lot of crazy mess to throw a whole bunch of electrons in. So this is why D is always going to be one behind. It takes less energy to skip out and go to that next energy level of S before you come back and fill in these D's. So I just wanted to show you the d orbitals. The f orbitals are even uglier, and so once again, you're not going to find a good simulation that shows those. What I do want to do, though, quickly here is talk about the orbital diagrams that you should have been looking at. So one of the things you were looking at was you were looking at the terms AFBOW principle. And AFBOW, you're going to want to think like alphabet. What that means is you're going to fill in the correct order. So like A, B, C, D, E, F, G. In this case, fill up 1S2 before you go on to 2S2, before you go on to 2P. Okay? So if you look at this example, they filled up 1S, filled up 2S, and then they started going through 2P. Good, not a problem. Let's look at this example. 1S, 2S went into 2P. So far, both of these guys followed AFBOW. You don't see any crazy 1S, 2S, and then jump to a 3S. That's not following the AFBOW principle. Okay? The second rule you were told about was Hund's rule. Hund's rule is like the bus seat rule. You're going to fill up every available seat before you double up. Think about getting on a bus with people you don't know. You're not going to go randomly sit with someone. So if you look at the two images that I have for you, one of these guys is violating the Hund's rule. Okay? Take a look up here. You filled the 2 and the 1S, filled 2 and 2S, and we got to 2P, and there are 3 orbitals in P. Okay, so remember, here I'll even pull it back up for you a second. Can go to the S orbitals and go to the 2P. Okay, when we looked at 2P, remember you had 3 different p orbitals. All right, so this is showing us that there's 3 different p orbitals. Okay, this is like the crazy person that just sat with you on the bus when there were available seats open. There's available orbitals open. This is not going to happen. This electron is not going to want to be next to this one because they're the exact same charge, so they're going to repel. This one right here is a violation of Hund's rule. So think Hund's bus, Hund's bus. You do not want to sit with someone unless you absolutely have to. This one violates it. Okay? So I'm going to get him out of there and come to this guy. This is the last rule that I want to talk about that was not on that activity. It's called Pauli's exclusion. Pauli's exclusion is kind of like the exclusive nightclub for electrons. So if in the movies you've seen someone who's standing at the door only allowing a certain amount of people in, and they're allowing, certain people in so that they can get everything going inside the nightclub. In a movie, you're not old enough to go. You will notice that they are controlling the amount of people, and they're usually picky about who they let in. So Pauli's exclusion is the exclusive nightclub for electrons. They're only going to let 2 electrons in each orbital. So notice 1, 2, 1, 2, 1, 2, 1, 1, but there could be another one that fits in here. So right now, in terms of the amount of electrons, hey, we're good, okay? But opposites attract. So in the movies and in TV shows, when you see people going into those places, they're only going to let people in that are going to get along and mingle. Because if everybody going in is somebody who's shy and doesn't want to talk to anybody and doesn't want to dance, it doesn't work. Okay? So the exclusive nightclub for electrons, they're not going to let two of the exact same type of electrons in, meaning spinning the same directions. They're going to repel, they're going to go crazy. You got to have one going one way and one going the other way, and that is shown by having two opposite arrows. This up arrow is telling you, no, you've got two of them going the same way. It doesn't work. This is a violation of the Pauli's exclusion. Okay, so you've got those three laws that you want to take a look at. You're going to go through now on a quick little quizzes and see how you're doing with this. Let me know if you have any questions. Okay, talk to you guys later.